Hi guys, I welcome you to another video of petrophysical analysis of well log data using Excel and TechLog software. You will recall in the previous video where we discussed the importance of learning petrophysical analysis using Excel. And I laid emphasis on why geoscientists and petrophysicists should have full understanding of how software like TechLog use their input data behind the scene. And then we started the analysis using Excel. And we stopped at volume of shales calculation. So in this video, we will continue with the analysis. But before we get started, please like this video, comment on it, share it with others, and subscribe for more interesting content like this. Alright? So after volume of shale calculation, the next step is to plot volume of shale against depth, so that we're able to identify our volume of shale cutoff. So let's open another sheet. Alright. And then let's copy the depth and volume of shale. Okay? As usual, let's press and hold Shift, End, and Down keys. Okay, and then Ctrl C, and then paste it in the second Excel sheet. All right, and then do the same for volume of shale. Shift, End, Down keys. Here you can't do Ctrl V or right click and paste. You have to do special pasting because we use the function to calculate the volume of shale. So we need to do special pasting. To do that, click on this icon, go to paste special, and then click on values, and then OK. Alright, so these are our volume of shale. The next step is to highlight the depth and volume of shale, and then press and hold Shift, End, and Down keys to highlight this data. Insert, click on this icon, and then click on More Scatter Charts, and then click on this icon, click on this log, and then say OK. Alright, so this is the log you have. So this is the plot of volume of shale against depth. Well, as you can see, the volume of shale is on y-axis, while the depth is on x-axis. And we are supposed to have our depth on y-axis, while the volume of shale will be on x-axis. Okay? So we need to interchange these axes. So, and to do that, double click on this axis, and then right click, select data, edit, and then type depth against volume of shale. All right. Volume of shale. Now, this is for depth. You need to change to volume of shale. Okay. So delete, and then click on volume of shale, and then press and hold Shift, End, and Down keys. Okay, and then come to Y values, delete, click depth, and then run the same procedure for copying the entire column. All right, Shift, End, and Down keys, say OK, and then click OK. Alright, now as you can see, we have successfully interchanged the depth and volume of shale axes. So the next step is to identify our volume of shale cutoff. So you will notice the volume of shale within these log curves is between 0.2 and 0.6 because of this concentration of shale around these log curves. So we are going to peg our cutoff around this 0.4. So our volume of shale cutoff is 0.4. Now let's bear that in mind. Okay. So after that, the next step is to differentiate sand from shale using this volume of shale cutoff. So what that means is within this data, we're going to differentiate which area is sand and which area is shale. So we're going to type sand stroke shale, okay, and then type a function that says equal sign if into brackets volume of shale is less than 2 or equals to 0.4, which is volume of shale cutoff, comma, let it be sand, put this sign up, and then type sand, and then close the sand with this sign, and then put a comma. Okay, let it be sand, otherwise let it be shale. Put this sign up, type shale, and then close it up with this sign. Close the bracket and then press enter. Alright, so at this level what we have here is shale. So double click at this edge to see our sand and shale within this data. Okay, so we have shale, we have sand. So we have sand from here down to this level, and then we have shale, sand. All right. Now, after this step, the next step is to calculate density porosity. And this is the formula for density porosity. This is matrix density, which is 2.65 grams per cm cube. This is our ρ B, which is found on this column. Okay. And then our fluid density, which is 1 gram per cm cube. Okay. So to calculate density porosity, we need to type density porosity, which is phi d density, and then type equal sign, open a bracket, and then type the metric density, which is 2.65 gram per cm cube, minus ρ B, this is our ρ B, over, open another bracket, and then 2.65 gram per cm cube minus 1 gram per cm cube, and then enter. Okay, so this is our density porosity, and then double click at the edge to have the full column. Now the next step is to calculate average total porosity, and the average total porosity is density porosity plus neutron porosity over 2. Okay, so that's our next calculation. All right, so type phi A average. Okay, and then bring in your equal sign, open a bracket, and then density porosity plus neutron porosity, close the bracket, all over 2, and then enter. Okay, so let's move this volume of shale away, or we can delete, but let's bear in mind that our volume of shale cutoff is 0.4. So let's delete this. Okay, this is our average total porosity. So at this point, let us double click here so that we can have the entire column. So this is average total porosity. So the next step is to calculate effective porosity, and this is the formula for effective porosity. This is average total porosity multiplied by 1 minus volume of V shell. Okay, so to start with, let's type the effective porosity and then bring in equal sign and then multiply average total porosity by 1 minus volume of shell, and then close the bracket, then press enter. Now this is our effective porosity. Okay, so let's reduce these decimal places to 2 decimal places, and to do that, click on this icon until you have 2 decimal places. All right, and then double click at this edge. So this is our effective porosity. Now fast forward to graph plots. The next thing we are going to do is to display gamma ray log and resistivity log as log curves. But before then, you will notice that the last exercise we carried out was effective porosity. And from this effective porosity, I have done a couple of things, such as dividing the data into reservoir and non-reservoir, calculating apparent water resistivity, calculating water saturation, down to calculating total sand and total shells. If you are willing to know all this and the use of Techlog software in calculating petrophysical parameters, you can go to my Udemy course. And at this time, I have 30% off coupon for the first 20 people who show interest. So if you are interested, kindly send me a message via this email address. All right? Now, back to the business. So for us to display gamma ray log, we need to plot gamma ray log against depth. So let's copy out the gamma ray values. Okay, to copy this column, press and hold Shift, End and Down key, and then Ctrl C. Go to the next Excel sheet. Okay, and then do Ctrl V. Yes, so this is our gamma ray. So we're going to plot depth against GR. Let's take away volume of shell and then move close the GR values to depth. Okay, so we're going to plot this against GR. So highlight depth and GR and then press and hold Shift and Down keys. Okay, click on Insert, click on this icon and then Most Scatter Charts. Click on this third icon and then click on the graph. Say OK. All right. But as you can see, we need to interchange these two axes. Okay. And to do that, double click on GR and then right click, select data, edit, type depth against GR. Okay, and then delete, and then bring in gamma ray log values. Highlight by pressing Shift, End and Down keys. Okay, and then for this space, also delete, and then bring in depth. Okay, so do the same thing for depth. Shift and Down keys and then say OK and OK. All right, so we have interchanged the depth and GR axes. Okay, and this is what we have. So this is our GR. All right, So the next step is to plot gamma ray against resistivity. So let's prepare for that. Let's bring this volume of shell close to GR and then bring in resistivity from the first Excel sheet. Okay, so this is our resistivity. Let's go up to copy it. Okay. So Shift and down keys to highlight, then Control C to copy, and then Control V. All right. Insert new column. Drag resistivity close to depth. All right. And then highlight and copy. And then insert. Click on this icon. And then most scatter charts. Click on this third icon as usual. And then click on this graph. Say OK. All right. So this is what we have. So this is resistivity and this is the depth. But we need to interchange the axes. So let's quickly do that. Double click on resistivity. And then right click. Select data. Edit. Depth against resistivity. Okay. And then click on this space. So you have depth on this space. So delete. And then bring in resistivity, highlight, press and hold Shift, End and down keys. And then for this Y value space, copy the depth. All right. Shift, End, down keys. Say OK. And then say OK. All right. So this is what we have. So we have successfully plotted the depth against resistivity. But if you take a close look at this log, you will find out that the log is in linear or automatic scale. But ideally, resistivity log is naturally in logarithmic scale because resistivity scale ranges from 0.2 to 2000 ohm meters, which is relatively a large scale compared with gamma ray log scale. So we need to change this linear scale to logarithmic scale, okay? And to do that, double click on the resistivity axis, particularly on the values. And then go to axis options, toggle on logarithmic scale. Yeah, so this is logarithmic scale, okay? So let us place resistivity log beside gamma ray log. All right? Place it side by side so that we're able to see what we have. And then let's extend this down. Okay. Now, if you look at these depth values, you see it runs from higher value to lower value. Okay. But it's supposed to be from lower value down to the higher value. You know, just like if you are drilling down or if you are logging down a particular well, you start from top and to the TD. So let's reverse the values of these depths. So double click on the depth axis and then click on values in reverse order. All right. So you have reversed it and then do the same for gamma ray log. Double click, click on values in reverse order. All right. So now you have from 6,600 down to 7,300. The same with resistivity log. Okay, so now we have placed them side by side and they are in the right depth. Okay, now let's remove this depth since we have one depth axis here to make our work more meaningful. All right, and to remove that, double click on this axis, particularly on the values, and then click on this icon and then labels. Click on this draw down and then click none. Yes, now we have removed this depth. Okay, so let's stretch this log out a little. Okay, and then do the same for resistivity log. Okay. Now, as you can see, we have the same color for gamma ray and resistivity log. So let's change these colors. Okay. So to change the color, click on the log and then click on this icon and then change the color from here, say red color. All right. Now this dialog box will pop up. Now what is this saying? All right, if you read through, it's saying complex formatting that is applied to the selected chart may take a while to display. Do you want to continue using the formatting? Say yes. All right, now we have red color for resistivity log. Okay, so now we are good to go. Now we are ready to carry out lithology identification, that is, differentiate our sands from shales. As you can see, we have a sand packet here, followed by this thick shale, and then another sand packet, and below this sand is a thick shale, and finally we have the largest sand packet here. Okay, so we have 3 different sand packets in this log, but we'll be focusing on these 2 sand packets, this one and then this one. Okay, so let's differentiate the sands from shales and then pick our tops. And to pick our tops, let's insert and then click on shapes, pick this object. Okay, and then pick your top. Okay, across, adjust it. All right, now this is our top. So let's make a copy of this object. Just right click, copy, and then Ctrl V. All right, so we have another copy and then place it here, which is the base of this particular sand. Okay, let's move a little to the center. All right, so let's adjust this very well. All right. Okay, so this is top and base of this particular sand, and then we're going to do the same for this sand packet. Okay, so now copy the top and the base of this sand, Ctrl C and then Ctrl V. All right, then drag down. Okay, so this is your top sand, and then move to the base, and this is your base. Okay, so increase the thickness of this object. I like the 4 object, and then come to this width, increase the width. All right, now we have top base of these sands. Okay, the next thing to do is to label these sands. So let's go to insert and then insert text box. Okay, and then place it here. All right, and then give it a name, say sand 1 top. Okay, and then do for the base, just say copy and paste. All right, and then change to base. All right, and then copy the both of them, copy, paste, and then drag down. Okay, drag the base down and then rename the sand to sand 2 top and then sand 2 base. All right, you can change the color around the font to white or red. Okay, white or red. Let's use this orange color. Okay, and then same thing for the base, orange. All right, and then for sand 2 top, let's change the color to another color, say yellow, yes, and then for the base, yellow. Okay, now we have San 1 top and San 1 base, and then San 2 top and San 2 base. Okay, now that we have been able to identify 2 reservoir sands, the next step is to calculate gross thickness, net thickness, net pay thickness, net to gross, average porosity, and average water saturation. So if you want to learn all of these and you want to know more about petrophysical analysis using Excel and TechLog software, you can go to my Udemy course. So kindly send a message if you are interested. And that is all I have for you in this video. If this video was of value to you, please like, share, and subscribe for more videos, because I still have more videos to share with you. Thank you and bye for now.